based on these values, how does the total mass of all living humans compare to the mass of all living ants? Okay? So what this question is really asking is, how many times bigger is mass of humans than ants? Okay? So we want to know how many times bigger are we than our small little insect friend here. And after reading this question for the first time, I've determined that there's really only one question we want to know. We want to know the how many times bigger. So some questions will ask us multiple parts. This particular question only has one part to answer for today. I'm just going to quickly reread the problem to help myself out, underlining important information that I see coming up. And here we go. The average mass of an adult human is about 65 kilograms. That's an important number. Average mass, adult human, 65 kilograms. While the average mass of an ant is approximately 4 times 10 to the negative 6 power kilograms. That's also important. Average mass ant, 4 times 10 to the negative 6 kilograms. Same units, good. And I know that's a really small number because it's a negative exponent. Okay, now we're going to be talking about the total human population. Well, that's going to be important too here, since I want to know the total mass, humans, total mass, ants. Well, the total human population is 6.84 billion, and it is estimated there are currently 10,000 trillion ants alive. Wow, that's a lot. And based on these values, how does the total mass of all living humans compare to the total mass of all living ants? That's what we want. So there's a lot underlined, a lot of important stuff. And the first part that I'm going to tackle is I'm going to write down some important numbers that I underlined here, which was the average mass of a human and the average mass of an ant, and from the problem they told us that those are equal to 65 and 4 times 10 to the negative 6th power, and those are both in kilograms. And I also know the total population of human is 6.84 billion people, approximately, and total pop of ants are 10,000 trillion. And since I'm working with such large numbers here, you guessed it, I'm going to use scientific notation. So if I want to make each of these numbers into a number times 10 to the power of some number, I'm going to quickly do that by moving the decimal from 65 at the end over one space to make it 6.5 times 10 to the first kilograms. This one's all set, our average mass of ants, so I'm just going to rewrite that here. And now working with these numbers, 6.84 billion. Well, I know that a billion has 9 decimal places, or the 10th being the billions place. So this number is actually 6.84 times 10 to the 9th power. And with trillions, that's going to be 12 decimal places plus our original 4 here to make 1 times 10 to the 16th power. Again, trillion has 12 decimal places. We have 4 in the 10,000ths here. So I'm using my laws of exponents in my head to say 1 times 10 to the 4th times 10 to the 12th is getting me the 16. And now that I have all my numbers in scientific notation, I can begin to calculate. Okay. And I'm going to start just like we did on Monday, by finding the total mass of all humans. If I know the average is 65 kilograms, and I know there's this many people in the world, how am I going to get that? I'm going to multiply the average mass of a human times the total population. And that'll tell me how many, or the weight or the mass of all of my humans. Okay. And I'm going to quickly just substitute in what I know here. I know the average mass of a human is right here, 6.5 times 10 to the first times total population of a human, 6.84 times 10 to the ninth. And we know how to multiply two scientific notation numbers. So I'm going to help myself out with a calculator and multiply these two numbers. 6.5 times 6.84 will give me 44.46, again using a calculator, times 10 to the, 10 to the first times 10 to the ninth. I'm multiplying, I add the exponents. So that's how much they weigh. And now I'm going to do the same thing, but for ants. Okay. Total mass of ants equals, again, the average mass of ants times the total the total population of ants. Again, where am I getting these numbers? Right here from what I labeled, what I know. So I know the average mass is 4 times 10 to the negative 6. I know the total population of ants is 1 times 10 to the 16th. I multiply those out. Again, 4 times 1, I'm using the commutative property. 4 times 1 is 4, times 10 to the power of negative 6 plus positive 16 gives me 10. So the weight of ants is 4 times 10 to the 10th power kilograms. And now I just want to do one last calculation, and I'm running out of room here, so I'm gonna break the rules. Don't tell anyone. And I'm going to extend the box for today. Because the last step, I need to find my answer. And I'm going to find my answer. Again, how do we compare in math? Compare means how many times bigger. How many times bigger means to, you guessed it, divide. So we're going to divide our total mass of humans that we found here. Total mass of humans divided by the total mass of ants. Substitute in what I know. And what I end up with, quickly dividing with the calculator here, I get 44.46 divided by 4 is 11.15 times 10 to the power of, now I'm dividing similar bases, so I subtract the exponents. 10 take away 10 is 0. Oh, and what do we know about 10 to the 0? Very good, it's 1. So this is 11.15 times 1, or just 11 times bigger. I'm going to squeeze in my final sentence here to say the total mass of humans is 11 times, or approximately 11 times, greater than mass of ants. And I am all done.